Okay. Today I just want to experiment recent development of generator. So here you can see here is the generator uh, call out. So this is where the personal is for. This is the call out. So I don't make use of it because uh, it causes vibration. You can see it causes vibration. So it causes vibration. Cause vibration. So I don't make use of it. I cut from here, cut from here. So like this one is better. It is better. So it rotates freely without much vibration because I cut the circular uh, iron. So then I would have weighed it here, but it balanced or put it here, but it balanced. This one now it can rotate without vibration. But this one complete colored, it's shaft. It causes vibration because the weight here and down here is not the same. So it will be vibrating. It will be vibrating. So I don't make use of it. So this is my previous shaft coupling. So now this is my latest coupling. So you can see how I do it. So I just cut here, just cut from here. So very very perfect, very very perfect. Okay. So now I'm gonna couple. I just want to show. I'm gonna couple this generator. What I want to experiment today is the reason why when you put load on the generator or when you short circuit it, the generator, the speed goes down. The speed goes down. Is because of lens effect. Lens effect. Because of lens effect. So I'm gonna demonstrate so that you see what I'm talking about. And we know that when a motor, this is a 12-volt brushless motor I'm gonna use to roll the generator. So you know that when a motor is rotating and you hold it by your hand or put it or use a apply any mechanical, it will consume more current from the input. So this is exactly what the lens cause in this generator. When you put load or short circuit it slow it down because you know that north and north doesn't attract, south doesn't attract, but north and south attract. So like pole doesn't attract, but unlike pole attract. So I'm gonna demonstrate so that you see what I'm talking about. Remember, this is the previous submission I'm using to run the experiment. Uh, is replace the ceramic magnet with the neodymium magnet. So it is neodymium magnet. So I'm gonna couple it. It is free now. It is free. Okay, so this is the base, the city where the I will mount to the generator. So let me connect it. So generator will mount. So this is the motor. I'm gonna couple it to the. Okay, so now let me mount it. It is easy to mount. Yeah. So now let me tight it. So I've now connect it. We rock it from here. So now it has been connected. So the reason why I showed this direct connection and also with belt is because if there is a alignment, misalignment, it will be this belt will be bending slightly without the shaft. But because when you weld it directly, assuming there is a misalignment, it will this motor will not run at its full speed and it will consume a lot of energy. So, but with this help of this belt connection, it will rotate at full speed and uh, less energy, uh, no energy loss. So now I'm gonna connect it. Okay, so I've already connected the motor, and this is the generator. I've already connected the capacitor. This is the load. This is about I think 100 watts, 100 watts bulb. So this is my 12 volt battery, 7 amp. So now I'm gonna put this lead wire to the positive of the battery. You can see the motor has already been set. Yeah. So now I'm gonna connect. So see the way. You see. Okay. So I want to experiment something here. I want to experiment something. Now this is my meter. So I'm gonna switch it on to the DC so that we measure the input currents. So on it. Yeah. think 20 amp maximum. So I'm gonna connect. I will put my terminal, the terminal of the the, the multimeter to the positive of the battery. So now I'm gonna let me remove the load. Okay, let me disconnect the load. Let me disconnect this 100 watts port now. Okay, let me run the motor from the terminal. Okay, so okay, let me check again. To my the meter cannot continue reading because it is 20 10 seconds. So continue reading it from the damage meter. Okay, what I want to try to demonstrate is that when you put load, when you put load on the generator, the input current from the motor will rise. So when you put load on the generator, the input current from the motor will rise. Okay, so now let's see it. You see it will change from big sound. Okay, you see it. Though there is no visible sound change, but when you check it, it is consuming the input current consumption will increase. Okay, so let me disconnect it. Let me disconnect it. So now what I found out that is the problem is the lens effect. So because of the lens, and that lens include when you talk about the law of thermodynamic and other things, it's because of the lens effect. So now, um, coming over here, this is a 3.5 volts, 3.7 volt lithium cell. So let me check the voltage, the voltage I will use. Okay, let me put it here. Let me put it over here. So now let me wait. Okay, 6.6 volts. 6 volts. So now I want to use this 6 volts to power these few coils I want here. So I want to use it to demonstrate how lens affect this generator. How lens affect this generator. When you put load, when you short circuit, then it is hard for it's hard for anything to move this shaft. So I want to demonstrate how it works. So now this is a few wine coils. Wine. This is a few about let's say around uh 80 tons. Let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. Okay, 50. It is 50 tons. It is 50 tons. So I've already pressed it now. So now I'm gonna connect it to the power source. Here is my magnet. It has the polarity is this side and this side. So now here is my piece of magnet, medium magnet. Okay. So now let me connect the power source here. Now, now watch what will happen now. As I'm bringing this magnet close to this coil, it will try to push it away. It will push it away. Then when this magnet I'm it is leaving, this magnet, this coil, because it has already formed electromagnetic, because I already connected to the power source here, which is 6 volts. So when this magnet is going out, this coil will try to attract it back. It's like a two brake. When this magnet is approaching this coil, it resists it. It resists the movement. And when this magnet is moving away, the coil now start to attract it. So now just watch. You can see it. Okay, it has not disconnected from power source. You see? I can experience a force. I can experience a force. So when this magnet is approaching the coil, it pushes it away. The reason why the magnet is shifting, because it didn't put it on the slot. So when the magnet approaches the coil, it resists it. But when it is moving away, the coil try to attract it. There's no physical uh, interaction. You see, it has rolled it. So this is exactly what happened in this generator. This is exactly what happened. This is exactly what happened. You see. So unlike, that's why you can see this. Oh my God! It has break. Wow! It's very strong magnet. Okay. So that is the experiment. So you can see now, it doesn't attract. No matter how force we apply, it doesn't attract. Like pole doesn't attract, but unlike pole, attract. You can see, does not attract. But when you turn it over, it won't attract. You can see it. So this is exactly what we are experiencing in this generator. This is exactly what we are experiencing when the north pole of the armature is coming close to the coil. This coil will form exactly north, and it will try to resist the motion. Assuming if this motor rotates clockwise, it rotates like this way, clockwise. It rotates clockwise. So when this north pole, assuming this north pole of generator is coming over, because this generator is a two-station, it is a two-pole, and this armature is a one north, one south. So assuming when north is approaching the coil form north, and it try to suppress the motion, it try to reverse the motion back, and that is a number one break. And by doing it, the motor consume more current from the input to maintain the rotation. Then when the north pole has considered leaving the coil, yeah, it is not going out. The same coil will form south, which we try to attract it back again. Exactly what we experience here. Exactly what we experience here. When I bring the magnet close to the coil resists it, resists the movement. Then when the magnet is going out, the coil is trying to attract it. Yeah, the coil is trying to bend to attract the motion. So this is exactly what happened in this generator. So if there is a way to eliminate it, we have a complete self-learning, because any load you put on this generator, the current in the input current will rise. So this is exactly what I found out that is the problem. This is exactly what I found out that is the problem. So any load you put on the generator, the input current will rise. So that is the main problem I found that is uh, uh, that is suppressing the charging back, because any load you put on it, the input current will rise. Because if this motor now, when you want to start, it consumes 2 amp. So when you read the generator, I think it consumes around, when I use my clamp meter, it consumes around 4 amp. So, but the moment you put on the load, it will correspond depending on the watts of the load. Assuming this is 100 watts, if I put 60 watts, it consumes around 5 amp. But the moment I put 100 watts, it goes up to 7 to 8 amp. So the amp consumption will depend on the load you put on it, because of what the lens affects. The like pole doesn't attract, but unlike pole attracts. So when the south pole of this armature is coming close to the coil form the same south. And when the south pole of armature have already succeeded leaving the same coil, it will now form knot to reverse the motion. Because the reason why this motor consume any type of motor consume current when you use it to load generator is because this motor doesn't like suppression or reverse the motion, because it is on the motion, either it run clockwise or anti-clockwise. So that is the what I found out that is the uh, problem. I use this experiment so that you guys will understand what I'm talking about. I use this so that it will open source, so that you guys will understand what I'm talking about. Because if I'm explaining it here, it will be difficult and complicated. So this is exactly because this is how this generator is wired inside, but it is wired in the slot, in the ion stator. So, but here it is air core. But remember that ion showed magnetism. Ion increased magnetism. So when it is in the ion, its strength will be double. Its strength will be double. So this is exactly what happened in the generator. When you put load, the input current will rise. No matter the motor, even if it is brushless, brush, induction, any type of motor, AC or DC, the input current will rise the moment you put load in the generator. The moment you draw load, you draw current from the generator. So that is exactly what happened. It's because of the lens. So if there is a way to divert or eliminate some amount of, because each coil have 2 break. This is a single coil. It has a 2 break. When the magnet is coming over, it resists it. Yeah, it pushes it away. Then when the magnet is leaving, it draw it back again. So 2 break. 2 break is what will happen in a single coil. 2 break. So if you have 2 coils, it will be 4 break. So because single coil has a 2 break, so 2 coils we have a 4 break. So that's why 4 pole generator we have more cogging. The higher the pole, the higher the cogging, and the lower you will generate voltage. This is a single 2 pole generator, north south. The armature is 1 north, 1 south. So it's like a 4 break in this generator, 4 break, because it is a one section up, 1 section down, 1 north, 1 south. So the armature is 1 north, 1 south. So it is a series connection. One section is series connection. Down section is also the same series connection, but it is in reverse connection. So it is in reverse connection. So that is exactly what happened. And this breaking effect we have more effect when you wind more turns. Understand? So that is exactly, that's why a motor that is more, we need a motor that has more torque. I can see this is a brushless motor, and it doesn't peak immediately. It takes time to peak. So what I want to demonstrate today is that the reason why when you put load, the current, some motors when you put load, it will start heating up. It's because of the lens effect, and because of the it depends on the type of load you put, you draw from this generator. So I hope you understand uh, what happened, the reason why it occur when you put load in the generator, the reason why the current rise increase. If you like my video, like, share, and comment. Thank you.